Hello everyone, I am Nitin Reddy from EC. My topic is a phase change memory as a secure main memory. Introduction. PRAM uses the unique behavior of chalcogenide glass, which can be switched between two states, crystalline and amorphous. With the application of it, recent versions can achieve two additional distinct states, effectively doubling its storage capacity. Originally researched in the 1960s, Jordan Moore of Intel wrote a research paper about the benefits and memory implications of chalcogenic glasses. A secure PCM main memory might become practical in a few years. There are three types: economic feasibility of PCM main memory, and page mode is compatible with security, and the last one is limiting extra write traffic overhead. Economic feasibility of PCM main memory. If within a few years the write endurance per cell and PCM components reach 256 M writes, then it could become feasible to build 16 GB memory using comparatively very small PA to PCMA translation table. For instance, using 64K blocks memory regions. As mentioned above, the secure PCM memory could be able to survive to an overwrite attack at a full 4 GB per second write bandwidth for 52% of an expected lifetime of 32 years. Second one is page mode is compatible with security. If PCM memories are used as main memory, then a page mode could be interesting as on current DRAM to limit the access latency and increase bandwidth when the memory read requests exhibit high spatial locality. Our PA to PCMA translation scheme is compatible with such page mode since regions are large enough to accommodate large page even split across several PCM components. Last one is limiting extra write traffic overhead. In this, we have considered that the overwrite traffic associated with a PA to PCMA translation modification could be as large as one extra PCM block write per 8 physical memory block writes. This overhead can be reduced by decreasing the probability of triggering to PA to PCMA translation. This could reduce the total endurance of system to the override attack, but may still remain acceptable, decreasing the probability of triggering a PA to PCMA translation. This could reduce the total endurance of system to the override attack, but may still remain acceptable if the cell write endurance is large. There are two types of memory. First one is volatile memory. The second one is non-volatile memory. In volatile memory, random access memory RAM, static RAM SDRAM, and dynamic RAM DRAM, content addressable memory, and cache controller. The second one is non-volatile memory. In this, ROM read-only memory, flash memory, magnetic storage, hard disks, floppy disk, magnetic tape, optical storage, and the dead tree. The secure main based main memory. Security principles. There are two types. First one is invisible PA to PCMA translation is required, and the second one is PA to PCMA translations must dynamically change. Invisible PA to PCMA translation is required if a malicious attacker know the PA to PCMA translation, then for a given PCM memory block B, he or she is able to figure out the address of the physical memory block that is mapped on B. If the PA to PCMA translation is made invisible from the outside of the PCM memory, then the attacker cannot retrieve the address of the physical memory block mapped on a given memory block. PA to PCMA translations must dynamically change. Our analysis of the RBSC scheme has shown that in order to resist a birthday paradox attack, The PA to PCMA translation of any physical block B has to be modified with a frequency higher than one time every WMAX possible writes on B. The PA to PCMA translation changes should be completely unpredictable from the outside of the PCM memory. In particular, there should be no restrictions on a new translation. If the PA to PCM translation changes should be completely unpredictable, then the PCM memory, in particular, there is no restrictions on the new translation. Physical properties. First one is slash and second one is changing bits must be across blocks. Requires a time to build up a charge of 1 millisecond and degrades with use 10,000 to 1 lakh writes. PRAM individual bits can be changed. Low power consumption degrades slowly 100 million. At 85 degrees 85 C data can last 300 years. Applications of PCM in embedded systems memory is used for code storage. Phase change memory enables new memory usage models which are used as storage memory for an embedded file system. In wireless systems, PCM server serves as an outstanding code execution memory and outstanding read mostly memory. PCM achieves the best overall cost while meeting the increasing performance demands of high-end multimedia wireless devices. In solid-state devices, PCM can be used in solid-state storage systems to store often accessed page and also to store those elements which are more easily managed while manipulated in place. As non-volatile memory, to reduce power consumption, PCM banks are turned off when they are in ideal state. PCM subsystem density envelope is not limited by the system power envelope constants. And some more applications of PCM is a digital technique that involves sampling an analog signal at regular intervals of and coding the measured amplitude into a series of binary values, which are transmitted by modulation of a pulsed or intermittent carrier. It is the standard technique in telecommunications transmission. And in the PCM is used in the satellite transmission system. It is used in space communication. It is used in telephony. The compact disc CD is a recent application of PCM. And the advantages and disadvantages of PCM are advantage of PCM. Encoding is possible in PCM. Very high noise immunity, better performance in the presence of noise, convenient for large distance communication. And the disadvantage of PCM are the circuit is complex, it requires a large bandwidth, and synchronization is required between transmitter and receiver. In conclusion, the PCM based main memory is more efficient because of its very low static energy consumption. To consider PCM memory as an industrial product, it should resist to software override attacks. Override attacks can be prevented by hiding the PCM memory address and then moving the physical memory block in PCM memory. PA to PCMA scheme allows the overall PCM main memory to resist to an override attack for a few high fraction of its expected lifetime. The scheme proposed in this reduces performance and memory intensive applications. If the promises of PCM technology are fulfilled, then it might become economically feasible to build a main memory from PCM memory component in the next few years. Such a PCM based main memory will particularly be attractive due to its low static energy consumption. However, to consider such a memory for an industry product, the PCM based memory could have to be able to resist to software override attacks targeting its physical destruction. Thank you.